What is important for the subsampling technique, because we are combining the Josephson stepwise waveform and the high frequency coming from the generator, we need to cover a very wide bandwidth. And that requires that we know the filter functions of our digitizer over a very wide band. And so we can use, for doing this, I will show you one way which we used here. So we can use a calibrator or a generator where we know the output, and then we just can connect these two instruments and start a reading and just going through the complete frequency band up to megahertz, for instance, by using the known output signal of the generator and applying this. Unfortunately, for most generators, which are very wideband, we don't know the output amplitude with a high precision. So what we are doing here now is we add a reference. This is a thermal converter reference, which we put in parallel. So we are doing it like this. So we take the output of this generator and combine it in parallel to the digitizer we are using. I'm showing it like this. Usually you should bring the instruments closer together to avoid any cables. And then we use this thermal converter, which is well known via AC-DC transfer calibrations up to very high frequencies with a very good uncertainty. And now what I can start for the measurement is I'm just starting the frequency sweep from low frequencies up to very high frequencies, and I compare the readings of these two. The thermal converter transfers the AC input to a DC voltage, which I'm measuring with this digital voltmeter. And I can program this that it's running automatically, and usually it takes very long. What I can show you here already is the typical measurement. This has been started for quite large frequency jumps, so the first data point is already at 100 kilohertz, and you see the measurement up to 4 megahertz, and this has been done for the digitizer working at a sampling frequency of 10 megasamples. That's the measurement of the digitizer, and this is the reference of my system, so I can correct the 8 digitizer measurements by the reference system, and based on this I can find a description of the digitizer filter function, and that's the basis for the program which is going then into the subsampling measurement routine. What is important is, because the generator is drifting over time, what we are doing is we are using a reference frequency. So we measure the base reference frequency, then we go for a higher frequency, and we go back to the reference frequency, that we can track the drift of this instrument for all the time. It's well known for AC-DC people, so it's like an AC-AC technique, and it's known that this instrument is working well for this operation.